Welcome to my video on the cross product or the vector product. Here we're going to do an example. This is lesson 8 in my series on vector mathematics. So first of all, the problem is we want to determine a unit vector perpendicular to a plane, and then the plane is going to be defined by two vectors here. We've got A is equal to 2i minus 6j minus 3k. These are our unit vectors. And B, which is equal to 4i plus 3j minus k. So these A and B are two vectors, and we want to define a unit vector. Remember, unit vectors have length 1, but they point in the direction, so they'll be perpendicular to this plane. So our method of solution here, first thing we want to do is we want to find A cross B, because we know that the cross product is going to be perpendicular, and that's going to be to make a vector, and that's going to be perpendicular to the plane of A and B. Let's change that to an and, A and B, not to confuse you there. So the way we do that, we've seen in previous videos, a simple way to do it is just to do it through a matrix determinant. Form this and just do them this way. It's just simple, it's kind of rote, but it works quite well. Okay, so now we want to do A, so we've got a 2 minus 6 minus 3. B is 4, 3, and minus 1. So there's our determinant. Now we break that out. We get I times the 2 by 2 determinant. We cross out this row and this column. So what we're going to get is minus 6, minus 3, 3, and minus 1. Now we subtract off the second 2 by 2 determinant. Now we cross out the top row and the middle column. So we're going to get 2 minus 3, 4 minus 1, plus k times the third one. And here we're going to do the top row again. This time it's the last column. So that's going to be a 2 minus 6, 4, 3. So now let's expand that out. So we got I. Now I'm expanding and working on this one right here. And so that's minus 6 times minus 1 minus a minus 3 times 3. That's associated with the I unit vector. Now, let's see what we've got here. We've got minus j times 2 times minus 1 minus 3 times 4. And then finally the k, expanding this one out. And all we're doing there is we're doing a cross multiplication. So we're going to get 2 times 3 minus 4 times minus 6. All right, so let's do the arithmetic here and see what we come up with. So minus 6 times minus 2 is 6, and then that's going to be a plus 9. So that's going to be 15i. Now on the j, we're working on this one now. That's minus 2, and then the minuses cancel on the minus and minus 3, so that's a plus, that's 12. Plus, let's see, we've got this minus 2, 12, so that's a 10. We got a minus sign there, so that's a minus 10j. And then we're going to do plus, if it is a plus, let's see, 6. And then that is minus times a minus, that's 24. Plus 6, that's 30, and that is a plus 30k. So that is going to be our cross product. So that's the first step in our solution because we needed the vector that's perpendicular to the plane. Now the second step in this is going to determine the unit vector. And so we know that A cross B is 15I minus 10J plus 30K. So that's going to be the vector perpendicular to the plane of the A and B vector. Now unit vector, we can define that, or the way they're written is it's A cross B divided by the magnitude of A cross B. So it just leaves the direction because you're subtracting out the magnitude. Okay, so in the numerator here we've got 15I minus 10J plus 30K. And the denominator now, when we have a cross product, now we'll take the magnitude of a vector, so that's going to be the square root. We take each individual term, so that's 15 squared, the coefficient, plus minus 10 squared, plus 30 squared. And working out the math on that, that's going to be 15I minus 10J plus 30K. And then I did the math on my calculator. Let's see, so we're going to get 225 is the first term plus 100 plus 900, which is 30 squared. So this is going to be 15I minus 10J plus 30K divided by the square root of 1,225, which, plugging that in the calculator, that just turns out to be 35. So that's 15 plus 35I minus 10 over 35J plus 30 over 35K. So now we want to reduce this down. We see everything's divisible by 5. So let's just divide everything by 5 in the numerator and denominator, and we're going to get our unit vector that way. So we're going to call n our unit vector here because it is normal to the surface and has length 1. So 15 divided by 3 by 5 is 3 over 7I minus, and then 10. So that's going to be 2 over 7J plus 6 over 7K. So now this is going to be the unit vector normal to the direction of the perpendicular to the plane of A and B. We did that through the cross product, and then we divided the cross product by its magnitude to normalize it.